We're continuing with example problems from the Taylor and Maclaurin series section. In this video, we're going to work problems related to the binomial series. So we're going to be given a function as shown here, and we want to find its Taylor series expansion, except unlike in the previous videos, we're not going to be doing this from the definition of the Taylor series. We're going to be instead using the binomial series as a reference. So similar to how in the previous section we built power series of functions or found them using the geometric power series with starting term, first term 1 as a reference, centered at 0. Okay, so here is the binomial series, and we went through the details of how this was developed in the textbook video, but also note that this is a Maclaurin series. We didn't think about the idea of doing this kind of function centered at something other than 0. And so with that, any Taylor series that we find is going to be a Maclaurin series, because again, we're using this as as the reference. Okay, but note that we aren't going to have to do any proof that this function is equal to the Taylor series that we find. They're automatically going to be equal because we already proved this equality. So if we build a power series of another function using, either integrating or differentiating this or just doing pattern matching, well, then they're already equal because we've proven this is equal. Okay, so I don't think we're going to be taking any derivatives here or integrals, but we're going to be doing pattern matching. So, okay, we've got this can be written as 1 minus x to the 1/4. Okay, so we're getting closer. Now let's do, so 1 plus minus x to the 1/4. And now there we go. Now we can see the pattern. We've got the binomial series with x equal to minus x and k equal to 1/4. So, okay, we've got the 4th root of 1 minus x is equal to the sum from n is equal to 0 to infinity, k, choose n, and then minus x to the n. So we could take out a minus 1 to the n. Okay, so there it is. There's the power series representation of the 4th root of 1 minus x right here, and we'll write out a few terms in a second. But first note that this is a power series. Why is it a power series? It's, at the end of the day, it's just a sum of x to the first, x squared, x cubed. Just doesn't have to be each term is, it could be x to the first, x cubed, x to the 5th, whatever, but just these power terms, these positive integer power terms with a constant coefficient out front. That's a function of n or k or whatever. That's a power series, okay? Now, this is a little confusing, if you, like this coefficient here, so we know that a choose b. This combination formula it's a factorial over a minus b factorial times b factorial. But you can't take a factorial of a something that's not an integer, right? In fact, the domain of a factorial is any non-negative integer. So this is kind of confusing because, k could be any real number. Well, if you look into it, technically you can evaluate this combination formula. It doesn't, the input here can be negative values or non-integers. And I'm not going to get into too much detail on all of that here, but the way you should look at it is this. So, well, let me bring that back. So the way you view it is you write it this way. So a factorial, we can rewrite, so okay, here's a, choose b. We can rewrite a factorial as a times a minus 1 times a minus 2 times, then all the way to a minus, then the right before b. This is a minus b plus 1. Okay, and then what we're left with then is a minus b factorial, right? This is a factorial. So then over a minus b factorial, b factorial. So these cancel, and we're left with okay, now actually, so for the, let's just focus on the binomial series. I don't want to get into too much depth on this combination formula, but because it might be the case that this can't, this term here can't be anything other than a positive integer. But you can see that if you have, this can be any real number using this formula here. The upper term, the a, can be any real number because we eliminated the factorial. But with the factorial here, this can only be a positive integer, and that's okay. That's n. So that's the idea. That's how you interpret the binomial series with this formula here. And okay, yeah, and actually, and you could go through the process yourself, but if you analyze this in relation to each term, it starts off like it's kx, then k times k minus 1 over 2 factorial, then k times k minus 1 times k minus 2 over 3 factorial, etc. That's the progression of the coefficients. So we can write out a few terms here. We've got, so n is 0, just positive 1. And then, so we've got 1 plus, or no, this is going to be minus now. 1 minus 1/4 x plus 1/4 times 1/4 minus 1 over 2 factorial x squared minus 1/4 minus 1 3 factorial x cubed plus, okay, now let's see if we can see a pattern here. So we've got, all right, we can bring this 4 into the denominator, and then 1/4 minus 1 is minus 3/4. So we can bring that 4 into the denominator. So we've got 4 times 2 factorial, and then 3, okay, and then let's see, we've got here, so 1/4 minus 1 is minus 3/4, and then 1/4 minus 2 minus 7/4, okay, so that's, what you can see is we're getting a 4 times 4 times 4 times 3 factorial, and then 1 times 3 times 7, and this will be negative out front because this will end up being positive, this term, because this is negative, so this ends up being positive, but it was negative to start with. Okay, x cubed, and then we should have a negative because we're going to get what? It'll be 1/4 times 1/4 minus 1 times 1/4 minus 2 times 1/4 minus 3. And that'll end up being negative. So every term's going to be negative. And we've got, so the 7/4, 1/4 should be a 9/4, right? Minus 12/4, or no, an 11. Okay. So yeah, we've got 4 times 4 times 4 times 4 times 4 factorial over 1 times 3 times 7 times 11 x to the fourth. Okay, so here we can see more of a pattern, at least starting from this term. So what we can do is we can do this. So one minus 1/4 x, and then minus the sum from n is equal to 2 to infinity. Okay, and we've got, so this is going to be 4 to the n times n factorial. And then, so actually, let's do the numerator first. So, okay. 3 times 7 times 4n minus 5. And then we'll have 4n, 4 to the n. Okay, so you see how this works? You start at 3 and you go all the way up to the 4 times n minus 5 term. So at n is equal to 2, 4 times 2 is 8, minus 5 is 3. So it's just going to be, this is just going to be 3. At n is equal to 3, you've got 12, minus 5 is 7. So it's just going to be 3 times 7. Okay, and then times x to the n. Okay, and there you go. There is the Maclaurin series expansion, the power series expansion of the fourth root of 1 minus x. Okay, now what about the radius of convergence? Well, okay, we know that the binomial series converges for the absolute value of x is less than 1. But we have this exact binomial series with, and it doesn't matter what k is. It doesn't matter what k is, the absolute value of x is less than 1. But we had minus x. Okay, so let's solve this absolute value inequality. The minus doesn't matter. It's just going to be the absolute value of x is less than 1. So it's going to be exact same as, yeah, the exact same as this. You put a minus sign inside of an absolute value, that just, the minus sign just goes away. It's like you never even put it in there. So it's this is the, just r is equal to 1. Okay, let's do the cube root of 8 plus x. This is equal to, so, okay, we want to factor out a 1/8, and you've got 1 plus x over 8 to the 1/3. Now we can apply this 1/3 power to the 1/8, so you've got 1/2, and then 1 plus x over 8 to the 1/3. So there you go. So we've got the binomial series with a constant 1/2 out front, x equal to x over 8, and k equal to 1/3. All right, so we've got the sum from n is equal to 0 to infinity. And then, so let's put the 1/2 out front for now. We might want to bring this in to, maybe it'll help with a pattern. So then k 1/3, and then, okay, so let's see, this is, we've got, there we go. Okay, so if we write out the first few terms, so when n is equal to 0, you've got 1. Then when n is equal to 1, you've got 1/3 x. When n is equal to 2, you've got 1/3 times 1/3 minus 1 over 2 factorial. And so that's going to be what? 1/3 times 1/3 minus 3 over 3. So 1/3 times minus 2 over 3. Okay, so that's going to be minus 3 times 3 times 2 factorial over 2 x squared. And then the next term, I'm assuming is going to be a minus. You're going to have 1/3 times minus 2/3 times, and then 1/3 minus 2 is minus 5/3. Well, no, this is going to alternate because we don't have an alternating term already there. So, okay, so plus, and then 3 times 3 times 3 times 3 factorial, and then 2 times 5, and then this should be minus. Okay, so we'll have 1/3. It'll be 2/3, 5/3, or minus 2/3 minus 5/3, and then minus, let's see, 1/3 minus 3 is going to be minus 8/3. So 3 times 3 times 3 times 3 times 3 factorial, and then 2 times 5 times 8. Oh, wait, this is x cubed here. And then x to the 4th plus. Okay, now would bringing in the 2 be helpful? I don't think so. Well, yeah, actually, why not? Let's do that. So, because it would just divide this out. And so why not, if it's easy to get rid of this factor of 2 without making the problem any more difficult, then why not? So 1/2 plus 1/6 x, then minus 3 times 3 times 2 factorial over 1 x squared plus 3 times 3 times 3 times 3 factorial x cubed minus 3 times 3 times 3 times 3 times 3 factorial like that. Okay, so we've got 8 plus the cube root of 8 plus x, and then 1/2 plus 1/6 x, and then we'll do, let's just do plus here, and then we'll incorporate the minuses with the alternating term. So, okay, the sum from n is equal to 2 to infinity. Okay, so we could do minus 1 to the first term is going to be negative. So we want to do n minus 1. So we'll get 2 minus 1, we'll get the negative sign, 3 minus, then when n is equal to 3, we'll make it positive, etc. Okay. Then we'll have, so let's do the numerator first. So we could do 1 times 5 times 8. Okay, And then, let's see, what would this next term be? We would have, this was 1/3 minus 3. And then, so now we'd have 1/3 minus 4 would be, so the next term would be 5 times 8 times 11. So 5 plus 3 is 8. 8 plus 3 is 11. So let's do this. Let's come back. It'll be easier. So okay, we've got minus 3 times 3 is 9. 9 times 2 is 18. Okay. Now, plus n is equal to 3 to infinity minus 1 to the n minus 1. Now we're going to starting here. And then, okay. Now, 5 times 8 times 11 times, okay, it should be 3, something with a 3 in. Okay, so yeah, it's 5 plus 3 times, what would it be? Would it be 3 times n minus 3? When n is equal to 3, you get 5. When n is equal to 4, you get 8. When n is equal to 5, yeah, okay. So, yeah, this is a sub n. This is the nth term. So this is 5 plus 3n minus 9 is equal to 3n minus 4. So this would be 3n minus 4. Okay, then we've got 1, 2, 3. So this is going to be 3 to the n times, and then just n factorial. And then x to the n. So is this right? So when n is equal to 3, you've got 9 minus 4 is 5. When n is equal to 4, you've got 12 minus 4 is 8. So you do 5 times 8. Yeah. That's it. And then the first term is positive and alternates. Okay. So there you go. There it is. Now the radius of convergence, what we do is we know that the radius of convergence of the binomial series is the absolute value of x is less than 1, but we have the absolute value of, we substituted x over 8 for x. Okay, so this is, we could take out the 1/8 is always positive, multiply both sides by 8, and there you go. See, so the radius of convergence is going to be equal to 8. Okay, so here we can write this as, factor out a 2, okay, now 2 to the minus 3 is 1 over 8. And there we go. We see that we've got this 1/8 out front of the binomial series, but then we have the binomial series with x is equal to x over 2 and k equal to minus 3. So okay, let's bring out the 1/8, and we've got, so minus 3n x over 2 to the n. So this is, okay, so minus 3, choose n, then Okay, and actually, since 8 is 2 cubed, and we have a 2 to the n here, let's go ahead and bring the 1 over 8 into the summation. So, okay. 2 cubed times 2 to the n. Okay. So we've got the first term is 1, but that's just, we have to also incorporate the 2 to the n plus 3. So when n is equal to 0, you've got 2 cubed. So this is 1 over 2 cubed. Okay, then plus kx, k is minus 3. So, and now we need to have another 2, this would be 2 to the 4th times x. And then I guess this is going to be a plus. Yeah, minus 3 minus 1 is minus 4 times minus 3. So that ends up being plus. And then you've got, so it's going to be 2 to the 5th times 2 factorial. And then 3 times 4, x squared. Okay, then let's see. Minus 3, minus 4, minus 5. So 2 to the 6th times 3 factorial. And then 3 times 4 times 5, x cubed. Plus, okay, you can see the pattern, 2 to the 7th times 4 factorial, 3 times 4 times 5 times 6, x to the 4th minus. Okay, and now we can look at, so these cancel, and you're left with what? 2. Okay, now the 4 factorial cancels with the 3 and 4, and you're left with 2. And then the next term would be 2 to the 8th times 5 factorial, 3 times 4 times 5 times 6 times 7, x to the 5th. These cancel, and you're left with just 2. 5 times, exactly, okay. So what we've got is, so, okay, 2 to the 6th, and then 2 to the 7th, and then 2 to the 8th, and we can continue on and see that we'll have 2 to the 9th, etc. Okay, now it would be nice if we could go like to the 4th, to the 5th, to the 6th, to the 7th. Like if we had these step up just one, well, we could do that. Let's make it so, okay, 2, all right, 4, 5, 6. Yeah, there we go. Okay, so now we can clearly see a pattern here. So we've got, okay, n is equal to 0 to infinity. Okay, we've got the alternating term first. That's going to be minus 1 to the n, because we start positive. And then in the denominator, we'll have 2 to the n plus 4. And then in the numerator, we'll have, let's see, n, yeah, okay, so n plus 1 times n plus 2. And then 2, okay, then x to the n. And then there we go. Cool. Now the radius of convergence, we replaced x with x over 2. So when is the absolute value of x over 2 less than 1? Take out the 1/2. Multiply both sides by 2. So r is equal to 2. Okay, so here we've got 1 plus minus x to the 3/4. So we have the binomial series with k equal to 3/4 and x equal to minus x. So we've got okay, so okay. So this is 1 plus 3, well, no, they get the alternating term, so we start with positive 1, so this could be 1 minus 3/4 x, then plus 3/4 times 3/4 minus 1. 3/4 minus 4 over 4 is minus 1 over 4. Okay, so you've got 4 times 4 times 2 factorial and a 3. Okay, now this should be a plus. You've got 3/4 times minus 1/4 times 3/4 minus 2. This is minus 5/4. So, okay, 4 times 4 times 4 times 3 factorial, and then 3 times 5. Oh, and there's a x squared here, x cubed here. Okay, and so I'm assuming 3/4 minus 3 is going to be, so 3 times 4 over 4. Oh, okay, 9 minus 9. Okay. So and then 3 times 5 times 9. Let's go one more. So we're going to have 4 times 4 times 4 times 4 times 5 factorial. And then 3/4 minus 4. So 4 times 4 over 4 is 16 over 4. It's minus 13. So, okay. 3 times 5 times 9 times 13. Oh, x to the 5th. Okay, so what is this doing? 3 plus 2 is 5. 5 plus 4 is 9. 9 plus 4 is 13. Let's go one more term. So minus 4 times 4 times 4 times 4 times 4 times 6 factorial, and then 3/4 minus 5. 5 times 4 over 4 is 20 over 4. That's 17. Okay, I see. So 3 times 5 times 9 times 13 times 17. Okay, so let's do this. Okay, so 1 minus 3/4 x minus 4 times 4 is 16. 16 times 2 is 32. 3 divided by 32, x squared. And then we should be able to start the series here. N is equal to 3 to infinity. Okay, now we need an alternating term. This is going to be n minus 1. The first term is going to be positive. Then the next term will be negative. Okay, now we start with 3 times 5. Well, we could look at it like this. It's 3 times, we're increasing by 4 every time, the multiplier. So it's like this. It's 3 times 5 times, we're not increasing by 4 here, starting not going from 3 to 5, but every number after 5 we are. So 9 times 13 times, and what's the nth term? Well, okay, the starting term is going to be 5. So it's a sub n. Think of an arithmetic sequence. So a sub n is 5 plus 4 times n minus 3. So when n is equal to 3, you've got 5. When n is equal to 4, you've got 5 plus 4. Yeah, exactly. So 5 plus 4n minus 12. So 4n minus 7. Like that. So this is 3 times 5 times 9 times 13. Okay. And then over 4 to the n times n plus, or no, just n factorial. And then x to the n. There we go. Now the radius of convergence is just going to be 1.